Jakarta enterprise beans. EJB, uh, Enterprise Java Beans technology is the server-side component architecture for Java Platform Enterprise Edition Java EE. EJB technology enables rapid and simplified deployment of distributed, transactional, secure, and portable applications based on Java technology. Here you can see a typical EJB architecture. An EJB object consists of a number of different objects. First one, bean itself, which must be written completely by the application programmer. Number two here, home object, which is responsible for creation and removal of a bean. This is automatically generated from an interface specification given by the application programmer. And EJB object, which acts as an RMI remote object visible to the client. It automatically generated from an interface specification given by the application programmer. A client to the EJB, which is written by the application programmer. The bean, home object, and the EJB object will all be embedded in an EJB container, which is run from an EJB server. These are supplied by the EJB vendor and are not the direct concern of the application programmer. Here you can see a client is connected to home and EJB object. Remote call is passed from client to home. Remote call is passed from client to EJB object. Home is connected to bean. Local call is passed from home to bean. EJB object is connected to bean. Local call is passed from EJB to objects to bean. Here you can see a life cycle of EJB 2.1 entity bean with container managed persistence. An entity bean is an EJB 2.1 enterprise bean component that manages persistent data, performs complex business logic, potentially uses several dependent Java objects, and can be uniquely identified by a primary key. This figure shows the EJB 2.1 CMP entity bean life cycle. There are three states: does not exist, pooled, and ready. To transition from does not exist state to the pooled state, the following occurs. New instant method is invoked and the set entity context method is invoked with the entity context argument, while the pool state EJB home EJB find and EJB select methods may be invoked to transition from the pool state to the ready state. Following occurs for a new instance. The EJB create method is invoked and the EJB post create method is invoked. While in the ready state, the following state to the pooled following methods may be invoked: EJB load, business methods, EJB timeout, EJB select, and EJB store. To transition from the ready method to the pooled state, the container select the entity bean as eligible for passivation and then invokes the EJB passivate method. To transition from the pooled state to the ready state, the following occurs for the previously passivated entity bean. The EJB activate method is invoked. The transition from the ready state to the pooled the following occurs for a removed entity bean. The EJB removed method is invoked. To transition from the pooled state to the does not exist state, unset entity context method is invoked. The EJB 2.1 enterprise beans lifecycle methods as specified in the javax.egb entity bean interface that an entity bean with container managed persistent must implement. For EJB 2.1 entity beans with container managed persistence, you must at least provide an empty implementation for all callback methods. EJB create method, you must implement an EJB create method corresponding to each create method declared in the home interface. When the client invokes the create method, the container first invokes the constructor to instantiate the object, then it invokes the corresponding EJB create method. For an entity bean with container managed persistent, use this method to initialize container managed persistent fields. The return type of all EJB create methods is the type of the bean's primary key. Optionally, you can initialize the bean with the unique primary key and return it. If you rely on container to create and initialize the primary key, return null. EJB post create, the container invokes this method after the environment is set. For each EJB create method, the EJB post create method must exist with this argument. For an entity bean with container managed persistent, you can leave this implementation empty or use your implementation to initialize parameters within or from entity context. EJB remove method, The container invokes this method before it ends the life cycle of the entity bean. For an entity bean with container manage persistent, you can leave this implementation empty or use your implementation to perform any required cleanup, for example, closing external resources such as field handles. EJB store method. This container invokes this method right before the transaction commits. It saves the persistent data to an outside resource such as database. For an entity bean with container manage persistent, you can leave this implementation empty. EJB load method. This container invokes this method when the data should be reinitialized from the database. This normally occurs after activation of an entity bean. For an entity bean with container manage persistent, you can leave this implementation empty. EJB activate. The container calls this method directly before it activates an object that was previously passivated. Perform any necessary reacquisition of resources in this method. EJB passivate. The container calls this method before it passivates the object. Release any resources that can be easily recreated in EJB activate and save storage space. Typically, you want to release resources that cannot be passivated, such as sockets or database connections. Retrieve these resources in the EJB activate method. Here, does not exist interacts with pooled new instance, then set entity context are passed from does not exist to pool. EJB home is passed from pool to pool, and EJB find then EJB select are passed from pool to pool. Pooled interacts with ready. EJB create, then EJB post create are passed from pool to ready. EJB loads are passed from ready to ready. Business methods are passed from ready to ready. EJB timeout are passed from ready to ready. EJB select is passed from ready to ready. EJB store is passed from ready to ready. EJB activate is passed from pool to ready. EJB passivate is passed from ready to pool. EJB removed is passed from ready to pool. Unset entity context is passed from pool to does not exist. Here you can see a life cycle of a message driven bean. The EJB container usually creates a pool of message driven bean instances. For each instance, EJB container performs these checks. First, if the message driven bean uses dependency injection, the container injects these references before instantiating the instance. 2. The container calls the method annotated at post construct, if any. Like a stateless session bean, a message driven bean is never passivated, and it has only two states, non-existent and ready to receive messages. At the end of the life cycle, the container calls the method annotated at pre-destroy uh, if any, the bean instance is then ready to garbage collection. Here you can see does not exist and ready. Dependency injection if any, then post construct callback if any is pass from does not exist to ready. On message is passed from ready to ready. Pre-destroy callback if any is passed from ready to does not exist. Message driven beans, here you can see messaging with MDBs in JMS Java EE programming. Message driven beans is one of family of enterprise Java beans EJB components described in the EJB 2.0 and later specification. Message driven beans provide asynchronous messaging. Other EJB components, session beans and entity beans, can only be called synchronously through a standard EJB interface. However, enterprise applications often need asynchronous messaging to allow server-side components to communicate without tying up server resources. Any application whose server-side component must respond to application events need an EJB component that can receive and consume messages without being tightly coupled to the message producer. In enterprise application, this capability must also scale under increased load. Message-driven beans (MDB) is an EJB component supported by a specialized EJB container. That provide distributed services for component it supports. The MDB implements the JMS message listener interface. The onMessage method written by the MDB developer is invoked when MDB container receives the message. OnMessage method consumes the message just as the onMessage method of the standard message listener object would. You do not remotely invoke methods on MDBs as you do on other EJB components. Therefore, no home or remote interface associated with them. Each MDB can consume messages from only single destination. The message can be produced by standalone JMS applications or JMS components or EJB components. As shown in this figure. Specialized EJB container supports the MDB. This MDB container creates instance of MDB and set them for asynchronous consumption of messages. The container set up a connection with the broker, including authentication, creates a pool of sessions associated with the given destinations, and messages are and manages the distribution of messages among pool sessions. Since the container controls the lifecycle of MDB instances, it manages the pool of MDB instances to accommodate incoming message loads. Associated with each MDB is a deployment descriptor that specified the connection factory attributes and destination properties that the container uses in setting up message consumption. The deployment descriptor can also include other information needed by deployment tools to configure the container. Each such container supports all instances of a single MDB. Here you can see a JMS message produces a JMS component or application, and this is connected to destination. EJB container is connected to destination. EJB instance is in EJB container. Here you can see JMS message service. Broker and destinations are inside JMS message service. Destinations are connected to MDB container. JMS message consumers. MDB instance is inside MDB container. It has MDB instance has on message method. As an example, here you can see the client view of a message-driven beans deployed in a container. To a client, a message-driven bean is simply a message consumer. The client sends the messages to the destination or endpoint, for which the message-driven bean is the message listener, just as it would do any other destination or endpoint. The message-driven bean, as a message consumer, handles the processing of the message. From the perspective of the client, the existence of the message-driven bean is completely hidden behind the destination or endpoint, for which the message-driven bean is the message listener. The diagram illustrates the view that is provided to a message-driven bean's clients. Client's JNDI namespace may be configured to include the destinations or endpoints of the message-driven beans installed in multiple enterprise beans containers located on multiple machines on a network. Actual locations of enterprise bean and enterprise beans container are in general transparent to the client using the enterprise bean. References to message destination can be injected, or they can be looked up in the client's JNDI namespace. Here you can see client is connected to destination or endpoint. Here you can see message-driven bean instances are inside message-driven bean, and message-driven bean is inside container. Here you can see message-driven bean is connected message-driven. Sorry, here the destination or endpoint interacts with the container message-driven bean here. Here you can see life cycle of a message-driven bean. When a client sends a message to a destination for which a message-driven bean is the consumer, the container selects one of its method ready instances and invokes the instance's message listener method. The following figure illustrates the life cycle of a message-driven bean instance. The following steps describe the life cycle of a message-driven bean instance. A message-driven bean instance life cycle starts when the container invokes the message-driven bean class constructor or create a new instance. Next, the container injects the bean's message-driven context object if applicable, and performs any other dependency injection as specified by the metadata annotations on the bean class or by deployment descriptor. Container then calls the bean's post-construct lifecycle callback methods, if any. Message-driven bean instance is now ready to be delivered a message sent to its associated destination or endpoint by any client, or a call from the container to a timeout callback method. When the container no longer needs the instance, which usually happens when the container wants to reduce the number of instances in the method ready pool, the container invokes the pre-destroy lifecycle callback methods for it, if any. This ends the lifecycle of the message-driven bean instance. Here you can see a message here does not exist interact with the message ready pool. Here does not exist is connected to method ready pool via step 1 around construct callback, if any. Step 2 constructor. Step 3 dependency injection, if any. Step 4 post construct callback, if any. Here message method ready pool is connected to method ready pool itself via message listener method. Here action resulting from client message arrival. Here message ready pool is connected to itself via timeout callback method, action initiated by the container. Here method ready pool is connected to does not exist via pre-destroy callbacks, if any. Now we are considering transaction diamond scenario with entity object. An entity object may be accessed by multiple clients in the same transactions. For example, a program A may start a transaction, a call program B and program C in the transaction context, and then commit the transaction. If program B and C access the same entity object, the topology of the transaction creates the diamond. An example not realistic in practice is a client program that tries to perform 2 purchases at different stores within the same transaction. At each store, the program that is processing the client's purchase request debits the client's bank account. It is difficult to implement an enterprise bean server that handles the case in which program B and C access an entity object through different network paths. This case is challenging because many enterprise bean servers implement the enterprise beans container as a collection of multiple processes running on the same or multiple machines. Each client is typically connected to a single process. If clients B and C connect to different enterprise bean container processes, and both B and C needs to access the same object in the same transaction, the issue is how the container can make it possible for B and C to see a consistent state of the entity object with the same transaction. The above in this example here illustrate a simple diamond. We use term diamond to refer to any distributed transaction scenario in which an entity object is accessing the same transaction through multiple network paths. Note that the diamond scenario, the client B and C access the entity object serially. Concurrent access to an entity object in the same transaction context would be considered an application programming error, and it would be handled by a container specific way. Note that the issue of handling diamond is not unique to the enterprise beans architecture. This issue exists in all distributed transaction processing systems. Here you can see a program A is connected to program B via TX1. Here program A is connected to program C via TX1. Program B is connected to TX entity object via TX1, and program C is connected to entity object via TX1, and entity object is inside the enterprise bean container. Here you can see the client view of entity beans deployed in a container. This diagram illustrates the view that a container provides to client of the entity beans deployed in the container. Note that a client may be a local client of some entity beans and remote client of others. Here the interface EJB object. The EJB object interface is extended by all enterprise beans remote interfaces. An enterprise beans remote interface provide the remote client view of an enterprise bean object. An enterprise beans remote interface defines the business methods callable by a remote client. EJB interface EJB home. The EJB home interface must be extended by all enterprise beans remote home interfaces. An enterprise beans remote home interface defines the method that allows a remote client to create, find, and remove enterprise bean objects. Interface EJB local object. The EJB local object interface must be extended by all enterprise beans local interfaces. An enterprise beans local interface provides the local view of an enterprise bean object. An enterprise beans local interface defines the business method callable by local clients. Interface EJB local home. The EJB local home interface must be extended by all enterprise beans local home interfaces. An enterprise beans local home interface defines the methods that allow local clients to create, find, and remove enterprise bean objects. Here you can see client is connected to EJB objects, and EJB home here entity in with entity bean 1. Here client is connected to EJB local objects and EJB local home. Here EJB objects and EJB home interacts with container and EJB bean 1 here. Here EJB local objects and EJB local home interacts with container and entity bean 2 here. Here entity bean 1 and entity bean 2 and other enterprise beans are inside the container. Here you can see client view of entity object lifecycle. This diagram illustrates a client point of view of an entity object lifecycle. The term referenced in this diagram means that the client program has a reference to through the entity object remote or local interface. The entity object does not exist until it is created. Until it is created, it has no identity. After it is created, it has identity. A client creates an entity object using entity bean's home interface, whose class is implemented by the container. When a client creates an entity object, the class obtains a reference to the newly created. The client object obtains a reference to the newly created entity object. And in an environment with legacy data, entity objects may exist before the container and entity beans are deployed. In addition, an entity object may be created in the environment via a mechanism other than by invoking create method of the home interface, for example by inserting a database record. But it still may be accessed via finder methods. Also, an entity object may be deleted directly using other means than the remove operation. For example, by deletion of the database record. The direct insert and direct delete transitions in this diagram represent such a direct database manipulation. All entity objects are considered persistent object. The lifetime of an entity object is not limited by the lifetime of the Java virtual machine process in which the entity instance executes. While a crash of the Java virtual machine may result a rollback of the current transaction, it does not destroy previously created entity objects nor invalidate the references to the home and component interface held by the clients. Multiple clients can access the same entity object concurrently. Transactions are used to isolate the client work from each other. The references to the entity object remote interfaces. The client can get the reference to an existing entity object's remote interface in any of the following ways. Receive the reference as a parameter in a method call input parameter or result. Find the entity object using finder method defined in the here you can see the client view of a message driven beans deployed in a container. To a client, a message driven bean is simply a message consumer. The client sends the messages to the destination or endpoint, for which the message driven bean is the message listener, just as it would do any other destination or endpoint. The message driven bean as a message consumer handles the processing of the message. From the perspective of the client, the existence of the message driven bean is completely hidden behind the destination or endpoint, for which the message driven bean is the message listener. This diagram illustrates the view that is provided to a message driven beans clients. Client's JNDI namespace may be configured to include the destinations or endpoints of the message driven beans installed in multiple enterprise beans containers located on multiple machines on a network. Actual locations of enterprise bean and enterprise beans container are in general transparent to the client using the enterprise bean. References to message destination can be injected, or they can be looked up in the client's JNDI namespace. Here you can see client is connected to destination or endpoint. Here you can see message-driven bean instances are inside message-driven bean, and message-driven bean is inside container. Here you can see message-driven bean is connected is message-driven. Sorry, here the destination or endpoint interacts with the container message-driven bean here. Here you can see life cycle of a message-driven bean. When a client sends a message to a destination for which a message-driven bean is the consumer, the container selects one of its method ready instances and invokes the instance's message listener method. The following figure illustrates the lifecycle of a message-driven bean instance. The following steps describe the lifecycle of a message-driven bean instance. A message-driven bean instance lifecycle starts when the container invokes the message-driven bean class constructor or create a new instance. Next, the container injects the bean's message-driven context object if applicable, and performs any other dependency injection as is specified by the metadata annotations on the bean class or by deployment descriptor. Container then calls the bean's post-construct lifecycle callback methods, if any. Message-driven bean instance is now ready to be delivered a message sent to its associated destination or endpoint by any client, or a call from the container to a timeout callback method. When the container no longer needs the instance, which usually happens when the container wants to reduce the number of instances in the method ready pool, the container invokes the pre-destroy lifecycle callback methods for it, if any. This ends the lifecycle of the message-driven bean instance. Here you can see a message here does not exist interact with the message ready pool. Here does not exist is connected to method ready pool via step 1 around construct callback, if any. Step 2 construct. Step 3 dependency injection, if any. Step 4 post construct callback, if any. Here message method ready pool is connected to method ready pool itself via message listener method. Here action resulting from client message arrival. Here message ready pool is connected to itself via timeout callback method, action initiated by the container. Here method ready pool is connected to does not exist via pre-destroy callbacks, if any. Now we are considering transaction diamond scenario with entity object. An entity object may be accessed by multiple clients in the same transactions. For example, a program A may start a transaction, a call program B and program C in the transaction context, and then commit the transaction. If program B and C access the same entity object, the topology of the transaction creates the diamond. An example not realistic in practice is a client program that tries to perform 2 purchases at different stores within the same transaction. At each store, the program that is processing the client's purchase request debits the client's bank account. It is difficult to implement an enterprise bean server that handles the case in which program B and C access an entity object through different network paths. This case is challenging because many enterprise bean servers implement the enterprise beans container as a collection of multiple processes running on the same or multiple machines. Each client is typically connected to a single process. If clients B and C connect to different enterprise bean container processes, and both B and C needs to access the same object in the same transaction, the issue is how the container can make it possible for B and C to see a consistent state of the entity object with the same transaction. The above in this example here illustrate a simple diamond. We use term diamond to refer to any distributed transaction scenario in which an entity object is accessing the same transaction through multiple network paths. Note that the diamond scenario, the client B and C access the entity object serially. Concurrent access to an entity object in the same transaction context would be considered an application programming error, and it would be handled by a container specific way. Note that the issue of handling diamond is not unique to the enterprise beans architecture. This issue exists in all distributed transaction processing systems. Here you can see a program A is connected to program B via TX1. Here program A is connected to program C via TX1. Program B is connected to TX entity object via TX1, and program C is connected to entity object via TX1, and entity object is inside the enterprise bean container. Here you can see the client view of entity beans deployed in a container. This diagram illustrates the view that a container provides to client of the entity beans deployed in the container. Note that a client may be a local client of some entity beans and remote client of others. Here the interface EJB object. The EJB object interface is extended by all enterprise beans remote interfaces. An enterprise beans remote interface provide the remote client view of an enterprise bean object. An enterprise beans remote interface defines the business methods callable by a remote client. EJB interface EJB home. The EJB home interface must be extended by all enterprise beans remote home interfaces. An enterprise beans remote home interface defines the method that allows a remote client to create, find, and remove enterprise bean objects. Interface EJB local object. The EJB local object interface must be extended by all enterprise beans local interfaces. an enterprise beans local interface provides the local view of an enterprise bean object. An enterprise beans local interface defines the business method callable by local clients. Interface EJB local home. The EJB local home interface must be extended by all enterprise beans local home interfaces. An enterprise beans local home interface defines the methods that allow local clients to create, find, and remove enterprise bean objects. Here you can see client is connected to EJB objects, and EJB home here entity in with entity bean 1. Here client is connected to EJB local objects and EJB local home. Here EJB objects and EJB home interacts with container and EJB bean 1 here. Here EJB local objects and EJB local home interacts with container and entity bean 2 here. Here entity bean 1 and entity bean 2 and other enterprise beans are inside the container. Here you can see a client view of an entity object lifecycle. This diagram illustrates a client point of view of an entity object lifecycle. The term referenced in the diagram means that the client program has a reference to an entity object remote or local interface. An entity object does not exist until it is created. Until it is created, it has no identity. After it is created, it has an identity. A client creates an entity object using the entity beans home interface, whose class is implemented by the container. When a client creates an entity object, the client obtains the reference to the newly created entity object. In an environment with legacy data, entity object may exist before the container and entity bean are deployed. In addition to an entity object may be created within the environment via the mechanism other than the invoking the create method of the home interface. For example, by inserting database record, but it still need to be accessed via the find methods. Also, the entity object may be deleted directly using other means other than remove operation. For example, by deletion from a database, deletion of a database record, the direct insert and the direct delete transitions in the diagram represent such direct database manipulation. All entity objects are considered persistent object. The lifetime of an entity object is not limited by the lifetime of the Java virtual machine process in which the entity bean instance executes. While a crash of the Java virtual machine may result a rollback of current transactions, it does not destroy previously created entity objects nor invalidate the references to the home and component interfaces held by clients. Multiple clients can access the same entity object concurrently. Transactions are used to isolate the client's work from each other. References to entity object remote interfaces. A client can get a reference to an existing entity object's remote interface in any of the following ways. Receive a reference as a parameter in a method call, input parameter or result. Find the entity object using the finder method defined in the entity beans remote home interface. Obtain a reference from entity beans handle. A client that has a reference to an entity object's remote interface can do any of the following: invoking business method on entity objects through the remote interface, obtaining reference to a to the enterprise beans remote home interface, pass a reference as a parameter or return value of a method, obtain an entity object's primary key, obtain entity object's handle, remove the entity objects. All references to an entity object that does not exist are invalid. All attempted invocation on entity object that does not exist result in Java java.rmi.no such object no such object exception being thrown. References to entity object local interfaces. A local can get reference to an existing entity object's local interface in any of the following ways: receive the reference as a result of a method call, find the entity object using the finder method defined in the entity beans local home interface, invoke a local can that has a reference to an entity object's local interface can do any of the following: invoke business method on the entity object through the local interface, obtain reference to an enterprise beans local home interface, pass the reference as a parameter, return a value of a local method call, obtain the entity object's primary key, remove the entity object. All local reference to an entity object that does not exist are invalid. All attempted invocations on entity object that does not exist result in a Jakarta EJB.no such object no such object sorry no such object local exception being thrown. A local interface must not be passed as an argument or result of a remote interface method. References to entity objects and stateful bean instance passivation and conversational state. If an entity bean is referenced from a stateful session bean, the bean provider is required to ensure the pre-passive methods lives in the instance field ready to be initialized by the container. In addition to the rules described in the enterprise beans core contracts and requirement document section, instance passive and conversational state for the entity bean references, the object are assigned to the instance such non-transient field after the session bean pre-passive method completes can also be one of the following: a reference to an entity beans local component interface even if it is not serialized, a reference to an entity beans local home interface if it is not serializable. Here you can see the client view of the entity object life cycle. Here you can see does not exist and not reference. It is connected. It's connected to exist and referenced via home.create method. Create action initiated by client. Here you can see does not exist and not reference is connected to exist and not reference via direct insert, and exist and not referenced is connected to exist and reference via home.find method. And here you can see exist and reference is connected to itself via object.business method. Here you can see exist and not reference is connected to itself via home.business method. Exist and reference is connected to does not exist and referenced via object.remove method or object.home.remove method or direct delete. And here does not exist and reference is connected to itself via object.business method, throws no such object exception, no such local object exception. Does not exist and reference is connected to does not exist and not reference via release reference. Here does not exist and reference is connected to exist and not reference via release reference. Exist and not reference is connected to does not exist and not referenced via direct delete to home.remove method. Here direct delete action on database from outside enterprise beans. Here you can see a view of underlying data sources accessed through entity beans. The enterprise beans component model provides a separation between client view of a bean as presented by its home and component interfaces and the entity bean class, which provides implementation of the client view. The enterprise beans architecture for container managed persistent adds to this separation between entity bean class as defined by the bean provider and its persistent representation. The container managed persistent architecture thus provides not only a layer of data independence between client view of a beans and as an entity bean and the bean provider internal view of the bean in terms of an entity bean instance, but also between the entity bean instance and its persistence representation. This allows an entity bean to be evolved independently from its client without requiring the redefinition or recompilation of these clients, and it allows an entity bean to be redeployed across different containers and different persistent data stores without requiring the redefinition or recompilation of entity bean class. In a container managed persistent, unlike in bean managed persistence, the bean provider does not write database access calls in the methods of the entity bean class. Instead, persistence is handled by the container at runtime. The entity bean provider must specify in the deployment descriptor those persistent field and relationship for which the container must handle data access. The bean provider codes all persistent data access by using the accessor methods that are defined for the abstract persistence schema. The implementation of the persistent field and relationships as well as all data access is deferred to the container. It is the responsibility of the deployer to map the abstract persistent schema of a set of interrelated entity bean classes into physical schema used by the underlying data store. For example, into a relational schema by using the containers providers tools. The deployer uses the deployment descriptor as the input to the container providers tools to perform this mapping. The container providers tools are also used to generate the concrete implementation of the entity bean classes, including the code that delegate calls to the accessor methods of the entity bean class to the runtime persistent data access layer of the container. The enterprise beans deployment descriptor for entity bean 2.1 entity beans describes logical relationships among entity beans. It does not provide a mechanism for specifying how the abstract persistent schema of an entity bean or of a set of interrelated entity beans is to be mapped to underlying database. This is the responsibility of the deployer, who using the container provider tools uses logical relationships that are specified in the deployment descriptor to map the physical relationships that are specific to underlying resource. It is the responsibility of the container to manage the mapping between the logical and physical relationships at runtime and to manage the referential integrity of the relationships. The advantage of using container managed persistent is that the entity bean can be logically independent of the data source in which the entity is stored. The container providers tools can, for example, generate classes that use JDBC or SQLJ to access entity state in a relational database, classes that implement access to non-relational data source such as an IMS database or classes that implement function calls to existing enterprise applications. These tools are typically specific to data source. Here you can see entity bean is an object view of the collection of related records in the database. Here the entity bean is an object view of the existing application. Here you can see client is connected to odd entity bean, which is in the container. Odd entity bean is connected to here odd 100 here. Connected to the database. Odd 100 is in the database here. Client is connected to odd entity bean. Odd entity bean is in the container here. Odd entity bean is connected to existing application. Existing application is connected to data source here, and odd 100 is inside the database here. Here you can see a relationship example. Relationship example illustrate an order entity, order entity bean with relationship to line items and customers, which are other entity beans within the same local scope. Product is indirectly related to order by means of the relationship between line item and product. So here you can see the order bean here. Order bean is has a one order bean can have one customer here. This order beans and customer interacts with the order customer here, and one customer can have many order beans. Order bean is aggregated with line items through via order line item. One order bean can have many line items. One line item can have one order bean. One line item is interacts with the product through product line item. So one line item in this relationship, one line item can have one product, and one product can have many line items. Here you can see a overview of the entity bean runtime execution model. The subscreen describes the runtime model and the classes used in the description of the contract between an entity bean and its container. This shows an overview of the runtime model. The client of an entity bean may be a client or maybe a local client, or it may be a remote client. An enterprise bean is an object whose class is provided by the bean provider. The class of the entity bean with container managed persistent is abstract. The concrete bean class is generated by the containers providers tools at the deployment time. The container is also responsible for providing the implementation of the java.util.collection classes that are used in the maintaining the container managed relationships of the entity bean. An entity EJB object or EJB local object is an object whose class was generated at the deployment time by the container providers tools. A client never references an entity bean instance directly. A client always references an entity bean and an entity EJB object or EJB local object whose class is generated by the container provider tools. The entity object class implements an entity bean's remote interface. The entity local object class implements an entity bean's local interface. A related entity bean never references another entity bean instance directly. A related entity bean, like any other local client of an entity bean, always reference an entity EJB local object whose class is generated by the container providers tools. An entity EJB home or EJB local home object provides lifecycle operations, create, find, remove for its entity object, as well as home business methods, which are business methods that are not specific to an entity bean instance. The class for the entity EJB home or EJB local home object is generated by the container providers tools at runtime, tools at deployment time. An entity EJB home or EJB local home object implements entity bean's remote or local home interface that was defined by the bean provider. Here, interface EJB object. The EJB object interface is extended by all enterprise beans remote interfaces. An enterprise beans remote interface provides the remote client view of an enterprise bean object. An enterprise beans remote interface defines the business methods callable by remote client. Interface EJB home. The EJB home interface must be extended by all enterprise beans remote home interfaces. An enterprise beans remote home interface defines the methods that allow a remote client to create, find, and remove enterprise bean objects. Interface EJB local home object. EJB local object interface must be extended by all the enterprise beans local interfaces. An enterprise beans local interface provides the local client view of an enterprise bean object. An enterprise beans local interface defines the business methods callable by local clients. The interface EJB local home. The EJB local home interface must be extended by all enterprise beans local home interfaces. An enterprise beans local home interface defines the method that allow local clients to create, find, and remove enterprise bean objects. Here you can see a client is connected to EJB object and EJB home. Here EJB objects and EJB home interacts with the container and enterprise bean here, and EJB objects and EJB home are connected to enterprise bean instances here. Here the client is connected to EJB local home, EJB local objects, and EJB local home, EJB local objects, and EJB local home interacts with container and enterprise bean 2 here. EJB local objects and EJB local home are connected to enterprise bean instances here. Here the enterprise bean is assigned in enterprise bean 1 and enterprise bean is assigned in enterprise bean 2. Here the this section enterprise bean 1 and enterprise bean 2 are in the container. Here this section EJB object, EJB home, EJB local object, EJB local home container provided classes, and here the enterprise bean instances. Here are classes and this in this section classes provided by bean provider and container here. Here you can see the life cycle of an entity bean instance. An entity bean instance is in one of the following 3 states. It does not exist. Pooled state. An instance in the pooled state is not associated with any particular entity bean identity. Ready state. An instance in the ready state is assigned an entity object identity. The following steps describe the life cycle of an entity bean instance. An entity bean instance life starts when the container creates the instance using new instance. The container then invokes the set entity context method to pass the instance a reference to the entity context interface. And the entity context interface allows the instance to invoke services provided by the container and to obtain the information about the caller of a client invoked method. And the instance enters the pool of available instances. Each entity bean has its own pool. While the instance is in the available pool, the instance is not associated with any particular entity object identity. All instances in the pool are considered equivalent, and therefore any instance can be assigned by the container to any entity object identity at the transition to the ready state. While the instance is in the pool state, the container may use the instance to execute any of the entity beans finder method shown as EJB find method in the diagram here, or any of the entity beans home method shown in the EJB home method in the diagram here. The instance does not move to the ready state during the execution of the finder or home method. An EJB select method may be called by an entity beans home method while the instance is in the pooled state, and the instance transitions from pooled state to the ready state when the container select that instance to service a client call to an entity object or an EJB timeout method. There are two possible transitions from the pool to the ready state through EJB create method and EJB post create methods, or through the EJB activate method. The container invokes the EJB create method and EJB post create methods when the instance is assigned to an entity object during the entity bean entity object creation. That is, when the client invokes a create method on entity bean's home object. The container invokes the EJB activate method on an instance when the instance need to be activated to the service an invocation on the existing entity object. This occurs because there is no suitable instance in the ready state to service the client call or the EJB timeout method. When an entity bean instance is in the ready state, the instance is associated with the specific entity object identity. While the instance is in the ready state, the container can synchronize the state of the instances with the state of entity in the underlying data source whenever it determines the need to, in the process invoking the EJB load, EJB store methods method 0 or more times. The business method can be invoked on the instance 0 or more times. Or EJB timeout method can be invoked on the instance 0 or more times. Invocation to the EJB load and EJB store methods can be arbitrarily mixed with the invocations of business methods and EJB timeout methods invocations. The EJB select method can be called by a business method, or EJB load or EJB store method or EJB timeout method while the instance is in the ready state. The container can choose to passivate an entity bean instance within the transaction. To passivate an instance, the container first invokes the EJB store method to allow the instance to prepare itself for the synchronization of the database state with the instance's state, and then the container invokes the EJB passivate method to return the instance to the pooled state. Eventually, the container will transition to the instance to the pool state. There are three possible transitions from the ready to the pooled state. Through EJB passivate method, through EJB removed method, and because of the transaction rollback for EJB create, EJB post create, or EJB remove. It's not shown in the life cycle of the entity bean instance here. The container invokes the EJB passivate method when the container wants to disassociate the instance from the entity object identity without removing the object. The container invokes the EJB remove method when the container is removing the entity object, that is when the client invoke remove method on the entity object's component interface or remove methods on the entity bean's home interface. If EJB create, EJB post create or EJB remove is called, and the transaction rollback, the container will transition the bean instance to the pool state here. When the instance is put back to the pool, it is no longer associated with any entity object identity. The container can assign the instance to any entity object within the same entity bean home. The container can remove the instance in the pool by calling unset entity context method on the instance. Notes the entity context interface passed by the container to the instance in the set entity context method is an interface, not a class that contains specific static information. For example, the result of the entity context.get primary key method might be different each time an instance moved from the pooled state to ready state. And the result of the get caller principle and isCaller in role method may be different from each business method. Step 2, a runtime exception thrown from any method of an entity bean class, including business methods and callback invoked by the container, results in the transaction to the does not exist state. The container must not invoke any method on the instance after runtime exception has been caught. From the caller's perspective, the corresponding entity object continues to exist. The client can continue accessing the entity object through its component interface because the container can use the different entity bean instance to delegate client's requests. 3. The container is not required to maintain a pool of instances in the pool state. The pooling approach is an example of a possible implementation, but it is not required implementation. Whether the container uses a pool or not has no bearing on the entity bean's coding style. Here you can see does not exist interact with pooled. does not exist, and here you can see instance throws a system exception from any method. Is connected to does not exist here. Does not exist is connected to pooled through via new instance, and set entity context easy to. Pool is connected to itself through via home EJB home method args, and pool is connected to itself via EJB find method args, EJB select method args. Here pooled interacts with ready. Pooled is connected to ready via EJB create method args and EJB post create method args. Pooled is connected to EJB via EJB activate. Here ready is connected to itself via EJB load, and ready is connected to itself via business method. Ready is connected to itself via EJB timeout args. Ready is connected to itself via EJB select, and ready is connected to itself via EJB store, and ready is connected to pooled via EJB passivate method here, and ready is connected to pool via here EJB remove method, and pooled is connected to does not exist via one here unset entity context method. Here you can see multiple clients access the same entity object using multiple instances. When writing the entity bean business methods, bean provider does not have to worry about concurrent access from the multiple transaction. The bean provider may assume that the container will ensure appropriate synchronization for entity objects that are accessed concurrently from multiple transactions. The container typically uses one of the following implementation to implementation strategies to achieve proper synchronization. These strategies are illustrative, not prescriptive. So we are here considering one implementation. The container activates multiple instances of the entity bean, one for each transaction in which the entity object is being accessed. The transaction synchronization is performed by the underlying database during the accessor method calls performed by the business methods. The EJB timeout method and EJB load, EJB create method, EJB store, and EJB remove methods. The commit time options B and C in commit options applied to this type of container. So commit options computation B is container caches a ready instance between the transaction. C is container does not cache a ready instance between transactions. With this strategy, the type of lock required by EJB load and EJB get accessor method is if the lazy loading cache management strategy is used, leads to trade-off. If the EJB load or the accessor method acquires a exclusive lock on the instances states in the database, the throughput of the read-only transaction could be impacted. If the EJB load or the accessor method acquires a shared lock and the instance is updated, then either EJB store or the set accessor method will need to promote the lock to an exclusive lock, which may cause a deadlock if it happens concurrently under multiple transactions. So if the container uses an optimistic cache concurrency control strategy, the container will need to validate the state of the cache against the database at the transaction commit, which may result in a rollback of the transaction. Here you can see client 1 and client 2 are connected to entity object account 100. Here the client 1 is connected to entity object account 100 via tx1. Client 2 is connected to entity object account 100 via tx2. Entity object account 100 connected to the container. So here you can see the enterprise bean instances. Entity object account 100 is connected to the entity object account 100 in tx1 here, and account 100 tx1 is connected to the account 100 to the database. The account 100 is inside the database, and here entity object account 100 is connected to the account 100 in tx2 here. Account 100 in tx2 is connected to the database in and account 100 is in the database here. So enterprise bean instances are in the container here. Here you can see multiple clients can access the same entity object using single instance. It is expected that the containers will provide deployment time configuration options that will allow control to be exercised over the logical transaction isolation level that their caching strategies provide. The container acquires exclusive access to the entity object's state in the database. The container activates the single instance and serializes the access from multiple transactions to this instance. The commit option A in the commit options apply to this container. Commit option A, the container caches a ready instance between transactions. Here you can see client 1 is connected to entity object account 100 via tx1. Client 2 is connected to entity object account 100 via tx2. Here entity object account 100 interacts with container, and entity object account 100 is connected to account 100 in tx1 here. And enterprise bean instances are in the container, and here the container blocks client 2 until client 1 finishes, and entity account 100 in tx1 is connected to database, and account 100 is in the database. Here you can see several entity beans with abstract persistent schemas defined in the same EJB-jar file. The following convention refers to the names used for the entity beans in the subsequent these examples. An entity bean as a whole is designated by name EJB, and its entity bean class and abstract schema type are designated by the name. Following convention is used to name the local interface of the entity of an entity bean. This example assumes that the bean provider provides several entity beans: order EJB, product EJB, line item EJB, shipping address EJB, and billing address EJB. The abstract schema types for these entity beans are order, product, line item, shipping address, and billing address, respectively. These beans are logically in the same EJB-jar file as shown here. Only two of the entity beans, order EJB and product EJB, have remote interfaces and remote home interfaces. The entity beans shipping address and billing address each have one to many relationships with order. There is also one to many relationship between order and line item. The entity bean line item is related to product in a many to one relationship. Entity beans query language QL allows the bean provider to specify finder queries for order EJB by navigating over the CMR fields and CMP fields defined by order and line item. A finder method query to find all orders with pending line items might be written as follows here. This query navigates over the CMR field line items of the abstract schema type order to find line items and uses the CMP field ships of the line item to select those orders that have at least one line item that has not yet shipped. Note that this query does not select orders that have no line items. Although predefined reserved identifiers such as distinct, object, from, as, in, where, and false appear in the uppercase in this example, predefined several identifiers are case insensitive. Select clause in this example designates the return type of this query to be the type of order. If this query is defined for a finder method on the entity bean's remote home interface, the finder method will returns objects of the entity bean's remote interface type corresponding to the abstract schema type instances selected by the query. If the same query is defined for the finder method on the entity bean's local home interface, the finder method will return the objects of the entity bean's local interface type corresponding to the same abstract schema type instances. Finder methods must always returns EJB objects or EJB local object of the bean type for which the query method is defined. Because the same deployment descriptor defines the abstract persistence schemas of the related entity beans, the beans provider can also specify the query for order EJB that utilizes the abstract schema of type of the product EJB. Hence, the comp field and CMR field of both abstract schema types order and product. For example, if the abstract schema type product has CMP dash field named product underscore type, a finder query for the order EJB can be specified using this CMP field. Such a finder query might be find all orders for products with product type office supplies. The enterprise beans QL query string for this might be as follows. Because order is related to the product by means of the relationships between order and line item and between line item and product, the navigation using the CMR fields line items and product is needed to express the query. This query is specified using the abstract schema name for order EJB, schema name for the order EJB, namely order, which designates the abstract schema type over which the query ranges. The basis for the navigation is provided by the CMR fields line items and product of the abstract schema types order and line item respectively. Here you can see a client view of underlying data sources accessed through entity bean. An entity bean implements an object view of an entity stored in the underlying database, or an entity implemented by existing enterprise application, for example. A mainframe program, or by an ERP application. The data access protocol for transferring the state of entity between the entity bean instances and the underlying database is referred to as object persistence. The entity bean component protocol for bean managed persistent allow entity bean provider to implement the entity bean's persistent directly in the entity bean class, or in the one or more helper class process provided with the entity bean class. This here. And here you can see entity bean is an object view of the record in the database. Client is connected to the account entity bean. Account entity bean is in the container, and account entity bean is connected to database, and account 100 is in the database. Entity bean here, entity bean is an object view of the existing application. Client is connected to the account entity bean. Account entity bean is in the container. Account entity bean is connected to the existing application. Existing application is connected to database. Account 100 is in the database. Of a simple stateless EJB. This is under EJB version 3.0. In this code, main points to note about on this code, use standard import statement to import metadata annotations you use in the bean file. Annotations that apply only to EJB 3.0 are in Java x.egb package. Annotation that can be used by other platform enterprise edition Java EE version 5 components are in more generic packages such as Java interceptor or Java annotations. The service bean file is a plain Java file that implement Java service, implement the service business interface. It is not required to implement any EJB specific interface. This means that the bean file does not need to implement the lifecycle methods such as EJB create and EJB passivate that were required in the 2.x programming model. The class level at stateless metadata annotation specifies that the EJB is of type stateless session. The class level at transaction attribute never annotation specified that the EJB never runs inside of a transaction. The class level annotation exclude default interceptors. Annotation is specified that the default interceptors, if any, are defined in the EJB-jar.xml deployment descriptor file, should never be invoked for any method invocation of this particular EJB. Here you can see a example of a simple stateful EJB as an example 2. This is in the version EJB version 3.0. Here use standard imports statement to import the metadata annotations you use in the bean file. Annotations that apply to EJB 3.0 are in the JavaX EJB package. Annotation that can be used by other Java platform. Enterprise Edition Java EE version 5 components are in the more generic packages such as JavaX Interceptor or JavaX Annotation. The account bean file is a plain Java file that implements the account business interface. It is not required to implement any EJB specific interface. This means that the bean file does not need to implement the lifecycle methods such as EJB create and EJB passivate that were required in the 2.x programming model. The class level at stateful metadata annotation is specified that the EJB is of type stateful session. The class level at transaction attribute never annotation is specified that EJB never runs inside of a transaction. The class level at remote annotation is specified the name of the remote interface of the EJB. In this case, it is the same as the business interface account. The class level at interceptors example dot audit interceptor dot class annotation is specified the interceptor class that is associated with the bean file. This class typically includes the business method interceptor method as well as lifecycle callback interceptor methods. The field level at EJB annotation specified the annotated variable service is injected with the dependent service bean stateful session bean context. The data type of injected field service is the business interface of service of the service bean. EJB. The following code in the say hello from account bean method shows how to invoke the say hello from service bean method of the dependent service bean. Service.say hello from service bean. The method level at exclude class interceptors annotation is specified that the at round invoke method specified in the associated interceptor class audit interceptor should not be invoked for the say hello say hello from account bean method. The method level at predestroy annotation is specified that the EJB container should invoke the predestroy method before the container destroyed an instance of the account bean. This shows how you can specify interceptor methods for both business methods and lifecycle callbacks in the bean file itself in adding to using an associated interceptor class. As an example 3, we can consider this. Implement the entity bean class. Here in this we can see the code segment here. Here in the full code, target methods for the method that are declared in the home interface, which include the EJB create and EJB post create methods with parameters matching the associated create method defined in the home interface, and finder methods other than EJB find by primary key and EJB find all that are defined in the home interface, and the container generates EJB find by primary key and EJB find all methods implementation, although you must still provide an empty method for each of these. Any home interface business method which are dependent with EJB home and in the bean implementation, for example calc salary method, it is implemented in the EJB home calc salary method. The business logic methods that are declared in the component interfaces, the methods that are inherited from javax.ejb.entitybean interface. So this is a segment of the class here. As an example 4, we can consider message driven bean class. For the code for the simple message bean class illustrate that the requirements of message driven bean class. It must be annotated with message driven annotation if it does not use a deployment descriptor. Class must be defined as public. The class cannot be defined as abstract or final. It must contain a public constructor with no argument. It must not define finalize methods. It is recommended but not required that the message driven bean class implement the message listener interface for the message type it supports. A bean that supports the JMS API implements javax.jms.message listener interface. Unlike session beans and entities, message driven beans do not have the remote interface or local interfaces that define client access. Client components do not locate message driven beans and invoke methods on them. Although message-driven beans do not have business methods, they may contain helper methods that are invoked internally by onMessage method. For the Glassfish server, the @message @message-driven beans message-driven annotation typically contains a mapped name element that specified the JNDI name of the destination from which the bean will be consumed messages. For complex message-driven beans, there can also be an activation config element containing activation config property. annotations used by the bean. A message-driven bean can also inject a message-driven context resource. Commonly, you use this resource to call the set rollback only method to handle exception for the bean that uses container managed transactions. As an example 5, we can consider this. To create an EJB, you must perform these steps. Step 1, create a remote interface for the bean. The remote interface declares the methods that a client can invoke. It must extend javax.egb.egb object. Step 2, create a home interface for the bean. The home interface must extend javax.egb.egb home. In addition, it defines the create method for your bean. Implement the bean. This includes following: the implementation for the methods declared in your remote interface, the methods defined in either javax.egb.sessionbean or javax.egb.entitybean interfaces. For the differences between these type of beans, then the EJB create method with parameters matching those of the create method defined of the home interface. Step 4, create the bean deployment descriptor. The deployment descriptor specified properties for the bean. Step 5, create an EJB-jar file containing the bean, the remote home interfaces, and the deployment descriptor. The EJB-jar file must define all beans within your application. So this is under Oracle 9.9. As an example 6, we can consider EJB application configuration. This is done under jboss.xml file in jboss application server. In the EJB application, you need to modify jboss.xml descriptor file for each stateful session bean and add the clustered tag. In the bean configuration, only the clustered tag is mandatory to indicate that the bean works in a cluster. The cluster config element is optional and its default attribute values are indicated in the sample configuration here. The session state manager GNDI name tag is used to give the JNDI name of the HA session state service to be used by this bean. The description of the remaining tags is identical to one for stateless session bean. Actions on the clustered stateful session bean's home interface are by default load balanced. Round robin anymore and will stay sticky to the first node in the list. as an now we are considering package Jakarta.EJB contains the enterprise bean classes and interfaces that define the contracts between the enterprise bean and its clients and between enterprise bean and the enterprise bean container. Now we are considering enterprise bean object types in overview. Message driven a typical message driven object has following characteristics: executes upon receipt of a single client message, is asynchronously invoked, can be transaction aware, may update shared data in an underlying database, does not represent directly shared data in the database, although it may access and update such data, is relatively short-lived, is stateless, is removed when the enterprise beans container crashes. The container has to re-establish a new message-driven object to continue computation. Typical enterprise beans container provide a scalable runtime environment to execute a large number of message-driven objects concurrently. Now we are considering overview in message-driven bean component contract. A message-driven bean is an asynchronous message consumer. A message-driven bean is invoked by the container as a result of the arrival of the message at destination or endpoint that is serviced by the message-driven bean. Message-driven bean instance is an instance of a message-driven class. A message-driven bean is defined for a single messaging type in accordance with the message listener interface it employs. To a client, a message-driven bean is a message consumer that implements some business logic running on the server. Client accesses a message-driven bean by sending messages to the destination or endpoint for which the message-driven bean class is the message listener. Message-driven beans are asynchronous. They have no client visible identity. Message-driven bean instances have no conversational state. This means that all beans instances are equivalent when they are not involved in servicing a client message. Message-driven bean instance is created by the container to handle the processing of messages for which the message-driven bean is consumer. Its lifetime is controlled by the container. Message-driven bean instance has no state for a specific client. However, the instance variable of the message-driven bean instance can contain state across the handling of the client messages. Example of such state include an open database connection and a reference to an enterprise bean. Now we are considering goals. The goal of the message-driven bean model is to make developing an enterprise bean that is asynchronously invoked to handle the processing of incoming messages as simple as developing the same functionality in any other message listener. The further goal of the message-driven bean model is to allow the concurrent processing of stream messages by means of container providing pooling of the message-driven bean instances. Now we are considering client view of a message-driven bean. For example, a reference to the queue for the Jakarta message-driven bean might be injected as follows. Alternatively, the queue for the stock info Jakarta messaging message-driven bean might be located using following code segment. Reminder, now we are considering Jakarta message-driven bean, considering message selectors in Jakarta message-driven beans in protocol between a message-driven bean instance and its container. Annotation type message-driven, a component defining an annotation for message-driven bean. This is in the package Jakarta.EJP. Bean provider may declare the Jakarta messaging Jakarta message selector to be used determining which messages a Jakarta message-driven bean to receive. If the bean provider wishes to restrict the messages that Jakarta message-driven bean received, the bean provider can specify the value of the message selector by using activation config element in message driven annotation, or by using activation config property deployment descriptor element. The property name is used to specify message selector is message selector. For example, here and here. The application assembler may further restrict but not replace the value of the message selector property of the Jakarta message driven bean. Now here we are considering now operations allowed in methods of a message driven bean class in message driven bean state diagram. Operations allowed in the methods of the message driven bean defines the methods of the message driven bean class in which the message driven bean instances can access the methods of the jakarta.ejb.message driven context interface, the jakarta.comp/n environment name context, resource managers, timer service and timer methods, and the entity manager and entity manager factory methods and other enterprise beans. The interface message driven context. The message driven context interface provides the access to the runtime message driven context that the container provides for a message driven bean instance. The container passes the message driven context interface to an instance after the instance has been created. The message driven context remains associated with the instance for the lifetime of the instance. This is in the package jakarta.ejb. If the message driven bean instance attempt to invoke a method of message driven context interface and the access is not allowed, the operation allowed in the methods of the message driven bean, the container must throw and log the java.lang.illegal exception. If the message driven bean instance attempt to invoke the method in the timer service or timer interface, and the access is not allowed in operations allowed in the methods of the message driven bean, the container must throw the java.lang.illegal exception. If the bean instance attempt to access a resource manager and enterprise bean or an entity manager or entity manager factory, then and the access is not allowed, the operation allowed in the method of the message driven bean, the behavior is undefined by the enterprise bean specification. Now we are considering the message driven bean class in the responsibilities of bean provider. The following are the requirements for message driven bean class. The class must implement directly or indirectly the message listener interface required by the messaging type that it supports all the methods of the message listener interface. In the case of Jakarta messaging, this is the jakarta.jms.message listener interface. The class must be defined as public, must not be final, and must not be abstract. The class must be a top-level class. The class must have a public constructor that takes no argument. The container uses this constructor to create instances of the message-driven bean class. The class must not define the finalized method. Optionally, the class may implement directly or indirectly the jakarta.ejb.message-driven bean interface. The class may implement directly or indirectly the jakarta.ejb.timed object interface. The class may implement the EJB create method. The class may have additional constructor annotated with the inject annotation. Message driven bean class may have a superclass or super interfaces. If the message driven bean has a superclass, the message driven listener methods, the lifecycle callback interceptor method and timeout callback methods, the EJB create method and methods of message driven bean interface may define in the message driven bean class or in any of its superclasses. The message driven bean class is allowed to implement other methods, for example helper methods invoked internally by the message listener method in addition to the methods required by the enterprise bean specification. Now we are considering generation of implementation classes in responsibilities of the container provider. The deployment tools provided by the container are responsible for generation of additional classes when the message-driven bean is deployed. The tools obtain the information that they need for generation of additional classes by introspecting the classes and interfaces provided by the enterprise bean provider and by examining the message-driven bean's deployment descriptor. The deployment tool may generate a class that mixes some container-specific code with the message-driven bean class. This code may, or for example, help the container to manage a bean instances at runtime. Subclassing, delegation, and code generation can be used by the tools. Now we are considering container managed transaction demarcation for message-driven beans in container providers' responsibilities in support for transactions. For these enterprise beans, the container must demarcate transaction as specified by the annotations on the bean class or in the deployment descriptor. The container is responsible for providing transaction demarcation for the message-driven beans that the bean provider declared as with container managed transaction demarcation. For these enterprise beans, the container must demarcate transaction as specified by the annotations on the bean class or in the deployment descriptor. Now we are considering not supported in container managed transaction demarcation for message listener methods. The container invokes the message-driven bean message listener method whose transaction attribute is set to not supported with an unspecified transaction context. If the message listener method invokes the other enterprise beans, the container passes no transaction context with the invocation. Now we are considering system exceptions in bean method runs in the context of the transaction that container started immediately before dispatching the method. This case happens with required attributes in exceptions from message-driven bean message listener method in container provider responsibilities in exception handling. Here you can see the container action. The class EJB exception. The EJB exception is thrown to report that the invoked business method or callback method could not be completed because of an unexpected error. For example, the instance failed to open a database connection. This is in the package jakarta.ejb. Log on the exception or error. Log on here the log the exception or error means that the container logs the exception or error so that the system administrator is alerted of the problem. Rollback the container started transaction. Discard instance. Discard instance means that the container must not invoke any methods in the instance. Throw EJB exception, the exception that wraps the original exception to resource adapter. Now we are considering message destination reference programming interface in interfaces in bean providers responsibilities in message destination references in enterprise bean environment. The following example illustrates how an enterprise bean uses a message destination reference to locate Jakarta messaging destinations. The bean provider uses message destination references to locate message destination as follows. Assign an entity in the enterprise beans environment to reference. Entity bean specification recommends but does not require that all message destination references be organized in the appropriate subcontext of the beans environment for messaging resource type. For example, in the Java :comp/n/jms JNDI context for Jakarta messaging destinations. Note that the message destination references declared via annotations will not by default appear in the subcontext. Look up the destination in the enterprise beans environment using EJB context lookup method or JNDI APIs. The following example illustrates how an enterprise bean uses message-driven destination references to locate a Jakarta messaging destination. In the example, the bean provider of the stock service bean, enterprise bean has assigned an environment entry jms/stock queue as the message destination reference name to refer the Jakarta messaging queue. If the JNDI API were used directly, the example would be as follows. Here you can see java :comp/anv/jms. Declaration of the message destination references in the deployment descriptor. Although the message destination reference is an entry in the enterprise beans environment, the bean provider must not use the environment env entry element to declare it. Instead, the bean provider should declare all references to the message destination using either the resource annotation in the bean code or in the message destination ref element in the deployment descriptor. This allows the EJB jar consumer to discover all the message destination references used by the enterprise bean. Deployment descriptor entries may also be used to specify injection of a message-driven reference into the bean. Each message destination ref elements describe the requirement that referencing enterprise bean has for the reference destination. The message destination ref element contains optional description, message destination type, and message destination usage elements, and the mandatory message destination ref name element. The message destination ref name element specifies the message destination reference name. Its value is the environment entry name used in the enterprise bean code. The name of the message destination reference is relative to the java :comp/env context. For example, the name should be jms/stock queue rather than java :comp/env/jms/stock queue. The message destination type element specifies the specified type of the reference destination. For example, in this case of a Jakarta messaging destination, its value might be jakarta.jms.queue. The message destination type element is optional. If an injection target is specified, the message destination reference, in this case, message destination type default to the type of the injection target. The message destination usage element specifies whether the message are consumed from the message destination produced for the destination or both. If the message destination usage element is not specified, messages are consumed to be both consumed and produced. The following example illustrates the declaration of message destination references in the deployment description. Look up the Jakarta messaging stock queue in the environment. Convert the result to the proper type. Obtain the default initial JNDI context. Look up the Jakarta messaging queue in the environment. Convert the result to the proper type. Now we are considering application assembler's responsibilities. The following example illustrates the use of message destination linking in the deployment descriptor. By means of linking the message consumers and producers to one or more common logical destinations specified in the deployment descriptor, the application assembler can specify flow of messages within an application. The application assembler uses message destination element the message destination link element of the message destination ref element and the message destination link element of the message driven element to link message destination reference to the common logical destination. The application assembly specifies the link between message consumers and producers as follows. The application assembly uses message destination element to specify logical message destination within an application. The message destination element defines the message destination name, which is used for the purpose of linking. The application assembly uses message destination link element of the message destination ref element of the enterprise bean that produces the link, produces the message to link it to the target destination. The value of the message destination link element is the name of the target destination as defined in the message destination name. Of the message destination element. The message destination element can be any module in the same Jakarta E application as referencing component. The application assembly uses message destination usage element. Of the message destination ref element to indicate that referencing enterprise beans produces the messages to the reference destination. If the consumer of messages from the common destination is message driven, the application assembly uses message destination link of the element message driven element to reference logical destination. If the application assembler links the message driven beans to its source destination, he or she should use the message driven type element of the message driven element to specify expected destination type. If the enterprise bean is otherwise a message consumer, the application assembly uses message destination link of the message destination ref element of the enterprise bean that consume messages to link the common destination. In the latter case, the application assembly uses the message destination usage element of the message destination ref element to indicate that the enterprise bean consumes message from the reference destination. To avoid the need to rename message destination to have unique names within the entire Jakarta E application, the application assembler may use the following syntax in the message destination link element referencing application component. The application assembly specifies the path of the EJB jar file containing the reference message destination, appends the message destination name of the target destination. Separated by the path name by hash. The path name is relative to the referencing application component jar file. In this manner, multiple destinations with the same message destination name may be uniquely identified. The linking message destination, the application assembler must ensure that the consumers and producers are for the destination require message destination of the same or compatible type as determined by the messaging system. The following example illustrates the use of message destination linking of the deployment descriptor. The application assembler uses message destination link element to indicate that the message destination reference employee employee reimbursement declared in the employee service. Enterprise bean is linked to the expense processing here you can here also see the application assembly uses message destination link element to indicate the message driven destination reference employee reimbursement declared in the employee service enterprise being linked to expense processing. Message driven bean by means of the common destination expose processing queue. The following example here illustrates using message destination link element to indicate that an enterprise being reference to the expose processing queue that is in the same Jakarta application unit but in a different EJB jar file. Now we are considering deployer's responsibility. The deployer is responsible for following. The deployer must ensure that all declared message destination references are bound to destination object that exists in the operational environment. The deployer may use, for example, the JNDI link ref mechanism to create symbolic link to the actual JNDI name of the target object. The deployer must ensure that the target object is type compatible with the type declared for the message destination reference. The deployer must observe the message destination link specified by the application assembler. Now we are considering container provider's responsibility. The deployment tools provided by the container provider must be able to process information supplied in the message destination ref and message destination link elements in the deployment descriptor. The container provider must provide the deployment tools that allows the deployer to perform tasks described. The deployment tools provided by the container provider must be able to process information supplied in the message destination ref and message destination link element in the deployment descriptor. The tools must be able to inform the deployer of the message flow between consumers and producers sharing common message destination. The tools must also be able to inform the deployer of any unresolved message destination references and allow him or her to resolve message destination reference by binding it to a specified compatible target object in the environment. Now we are considering entity objects optional in enterprise bean object types in overview. A typical entity object has the following characteristics. It's a part of a domain model providing an object view of the data in the database, can be long-lived, lives as long as the data in the database. An entity and its primary key survive the crash of the enterprise beans container. If the state of the entity bean was being updated by the transaction at the time of the container crash, the entity state is restored and to the state of the last committed transaction when the entity is next retrieved. Now we are considering entity bean removal in bean provider's view of the timer service in timer service. If an entity bean is removed, the container must remove the timers for that bean. Now we are considering locating an entity bean's home interface in enterprise beans container in client view of the entity bean. If dependency injection is used, the home interface could be obtained as follows. Annotation type EJB indicates the dependency on the local and no interface or remote view of an enterprise bean. This is in the package Jakarta.ejb. The client obtain an entity bean's home interface through dependency injection or locates an entity bean home interface using JNDI. The client's JNDI name space may be configured to include the home interface of the enterprise beans deployed in multiple enterprise beans containers located on multiple machines on the network. The actual location of the enterprise beans container is in general transparent to the client. For example, the local home interface for account entity bean can be located using following code segment here. If dependency injection were used, the home interface could be obtained as follows. Now we are considering entity bean provider's view of container manage persistence in enterprise bean 2.1 entity beans component contract for container manage persistence. And here are remove protocols and remove methods. Once the shipping address here object used by order has been removed, the billing address accessor method will also return null. Here the void EJB remove method, a container invokes this method before it removes the enterprise bean object that is currently associated with the instance. This is in the interface entity bean and package Jakarta.ejb. When the remove method is invoked in an entity object, the container must invoke the entity beans provider's EJB remove method as remove method. After beans provider's EJB remove method returns and the prior to return into the client, the container must remove the entity object from the all relationships in which participate and then remove the persistent representation. Once an entity has been removed from relationship, the accessor method for any relationship to the entity will reflect this removal. The accessor method for one-to-one or many-to-one relationship to entity will return null. Accessor method for many-to-many relationship of the entity will return calculation from which entity object has been removed. The container must detect any subsequent attempt to invoke an accessor method on the removed entity object and throw a java.rmi.no such object exception in the client is a remote or remote client, or the Jakarta.ejb.no such object local exception if the client is a local client. The container must detect and attempt to assign a removed no such object or local exception if the client is a local client. The container must detect and attempt to assign removed entity object as the value of the CMR field or another object with an argument to a set accessor method or an argument to a method of java.util collection API and throw the java.land.illegal argument exception. After removing the entity object from the old relationships and removing its persistent representation, the container must then cascade the removal to all entity beans with which the entity has been previously in container managed relationships for which cascade delete option is specified. More than one relationship may affect the removal of an entity object as in this following example. Once the shipping address object used by the order bean has been removed, the billing address accessor method will also return null. The remove method alone causes only the entity on which it is invoked to be removed. It does not cause deletion to be cascaded to other entity object. In order for the deletion of one entity object to be automatically cascaded to another, the cascade delete mechanism should be used. Both relationships now reference to the same entity object. It must be. This is impossible. Now we are considering identification variables in the from clause of navigational declarations in enterprise bean QL definitions in EJB 2.1 query language for container managed persistent query methods in enterprise beans QL. An identification variables evaluates to a value of the type expression used in a declaring variable. For example, consider this query. An identification variable is a valid identifier declared in the from clause of an entity beans QL query. Identification variable may be declared using an special operators in and optionally as. All identification variable must be declared in the from clause. Identification variable cannot be declared in other clauses. Identification variable must not be reserved identifier or have the same name as any of the following: abstract schema name or EJB name. Identification variables are case sensitive. An identification variable evaluates to a value of the type of expression used in a declaring variable. For example, consider this query for order EJB. In the from clause declaration in order line items L, the identification variable L evaluates to any line item value directly reachable from the order. The CMR field line items is a collection of instances of the abstract schema type line item, and the identification variable L refers to an element of this collection. The type of L is abstract schema type of line item. Identification variable ranges over the abstract schema type of an entity bean. An identification variable designate an instance of an entity bean abstract schema type or an element of a collection of entity bean abstract schema types instances. Identification variables are existentially qualified in an enterprise beans QL query. In identification variable always designates a reference to a single value. It is declared in one of two ways: as a range variable or as a collection member identification variable. A range variable declared using abstract schema name of an entity bean. Collection member identification variable is declared using collection value path expression. And an identification variable declarations are evaluated from left to right in the from clause. A collection member identification variable declaration can use the result of preceding identification variable declaration of the query string. Now we are considering single object finder in finder method return type in overview of bean managed entity persistence in enterprise bean 2.1 entity bean component contract for bean managed persistence. The following code illustrates the definition of a single object finder on the remote home here on the remote home interface. Some finder methods such as EJB find by primary key are designed to return at most of the one entity object. Here the class interface entity bean. The entity bean interface is implemented by every entity bean class. The container uses the entity bean methods to notify the entity bean instances of the instances lifecycle event. This is in the package Jakarta.ejb. For a single object finder, the result or type of a find method defined in the entity bean's remote home interface is the entity bean's remote interface, and the result type of the find method defined in the entity bean's local home interface is the entity bean's local interface. The result type of the corresponding EJB find method defined in the entity's implementation class is the entity bean's primary key type. Following code illustrates the definition of a single object finder on a remote home interface. Note that finder method defined in the local home interface, however, must not throw a remote exception. Entity's home interface. Entity's implementation class. Now we are considering EJB create and EJB post create in enterprise bean 1.1 entity beans with container managed persistence in enterprise beans 1.1 entity bean component contract for container managed persistence. With bean managed persistence, the entity bean provider is responsible for writing the code that insert the record into the database in the EJB create methods. With bean managed however, with the container managed persistence, container perform the database insert after EJB create method completes. The container must ensure that the values of the container managed fields are set to the Java language default, for example 0 for integer, null for pointers, prior invoke in the EJB create method on an instance. Then enterprise bean 1.1 entity bean provider's responsibility is to initialize container managed fields in the EJB create method from the input arguments, such as that when the EJB create method returns, the container can extract the container managed fields from the instance and insert them into the database. EJB create methods must be defined to return the primary key class type. The implementation of EJB create method should be coded to return null. The return value is ignored by the container. Note the above requirement is to allow the creation of an entity bean with bean managed persistence by subclassing an entity bean 1.1 entity bean with a container managed persistence. The Java language rules for overriding methods in subclasses requires the signature of the EJB create methods in the subclass and the superclass to be the same. The container is responsible for creating entity objects representation in the underlying database, extracting the primary fields of the newly created entity bean representation in the database, and for creating the EJB object reference for the newly created entity object. container must establish the primary key before it invokes EJB post create method. The container may create the representation of the entity in the database immediately after EJB create return, so it can defer it to a later time. For example, the time after the matching the EJB post create has been called or to the end of the transaction. Container then invokes the matching post EJB post create method on the instance. The instance can discover the primary key by calling get primary key method on its entity context object. The container must invoke EJB create, perform the database insert operation, and invoke EJB post create in the transaction context determined by the transaction attribute of the matching create method, as described in the enterprise beans contract requirement document subsection container managed transaction demarcation for business methods. The container throws duplicate key exception if the newly created entity object would have the same primary key as one of the existing entity objects within the same home. Now we are considering specification of the attributes for bean methods in bean providers responsibilities in support for transaction. The transaction attributes are specified for the method defined in the beans component interface and all the direct and indirect super interfaces of the component interface, excluding get EJB home, get EJB local home, get handle, get primary key, and is identical methods. Here the EJB home, get EJB home, get EJB home obtain the enterprise beans remote home interface. The EJB local home get EJB local home obtain the enterprise beans local home interface, and here get handle obtain a handle for enterprise bean object, and get primary key obtains the primary key of the enterprise bean object, and is identical test if the given enterprise bean object is identical to the invoked enterprise bean object. These are in the interface EJB object and the package Jakarta.ejb. The bean provider of an enterprise bean with the container managed transaction demarcation may specify transaction attributes for the enterprise bean methods. A transaction attribute is a value associated with the method of an entity bean's home or component interface. Transaction attributes are specified for the method defined in the bean's component interface and all the direct and indirect super interfaces of the component interface, excluding get EJB home, get EJB local home, get handle, get primary key, and is identical methods for the method defined in the bean's home interface and all direct and indirect super interfaces of the home interface, excluding get EJB metadata and get home handle methods specific to the remote home interface, and for the timeout callback methods, if any. For entity beans that use container managed persistent, only requires new and mandatory deployment descriptor transaction values should be used for method defined in the beans component interface and all the direct and indirect super interfaces of the component interface, excluding get EJB home, get EJB local home, get handle, get primary key, and is identical method for this method defined in the beans home interface and all direct and indirect super interfaces of the home interface, excluding get EJB metadata and get home handle method specific to the remote home interface. The bean provider and application assemblers must exercise a caution when using requires new transaction attributes with the navigation of the container managed relationships. At higher levels of the isolation are used, navigation of a container managed relationship in a new transaction context may result in deadlock. Containers may optionally support the use of not supported supports and never transaction attributes for the methods entity of the entity beans with the container managed persistence. However, entity beans with container managed persistent that use transaction attributes will not be portable. Container may optionally support the use of not supported support and never transaction attributes for the method entity beans with the consumer managed persistent because the use of these transaction modes may be needed to make the use of container managed persistent with non-transactional data stores. In general, however, the bean provider and application assembler should avoid use of these not supported support and never transaction attributes values for the methods of entity beans with container managed persistent because it may lead to consistent result or to the consistent and or to the partial updating of the percentage state and relationship in the event of concurrent use. Now we are considering application exceptions in exception handling. The Jakarta EJB create exception, Jakarta.ejb.remove exception, and Jakarta.ejb.find exception, and subclasses thereof are application exception used to report the errors to the client from the create, remove, and find methods in the EJB home or EJB local home interfaces of entity bean components. Here the class create exception, the create exception must be included in the throws clauses of all create methods defined in the enterprise beans home or local interface. The class remove exception, the remove exception is thrown at an attempt to remove an enterprise bean object or local enterprise bean object when enterprise bean or the content does not allow the enterprise bean object to be removed. The class find exception, the find exception must be included in the throws clause of every find method of the entity beans home or local home interface. These are in Jakarta, in the package Jakarta.ejb. Now we are considering the timer service interface in the beans provider's view of the timer service in timer service. For an enterprise bean 2.1 entity bean, the result of a get timers is a collection of those timers that are associated with bean's identity. The collection timer get timers returns all active timers associated with this bean. These include both programmatically created timers and the automatically created timers. This is in the interface timer service and in the package Jakarta.ejb. Now we are considering bean provider's responsibilities in deployment descriptor. The bean provider is responsible for providing following structural information for entity bean in the deployment descriptor. Re-entry indication, the bean provider must specify whether an entity bean is re-entrant. Entity bean's persistent management. If the enterprise bean is an entity bean, the bean provider must use the persistent type element to declare whether persistent management is performed by the enterprise bean or by the container. Entity bean's primary key class. If the enterprise bean is an entity bean, the bean provider specifies the full qualified name of the entity bean's primary class in the prime key class element. The bean provider must specify the primary key class for an entity bean with bean managed persistent. Entity bean's abstract schema name. If the enterprise bean is an entity bean with container managed persistent and CMP version 2.x, the bean provider must specify the abstract schema name of the entity bean using abstract schema name element. Container managed fields. If the enterprise bean is an entity managed with entity bean with container managed persistent, the bean provider must specify the container managed fields using the CMP field element. Container managed relationship. If the enterprise bean is an entity bean with the container managed persistent and CMP version 2.x, the bean provider must specify the container managed relationship of the entity bean using the relationship element. Find and select queries. If the enterprise bean is an entity bean with container managed persistent and CMP version 2.x, the bean provider must use the query element to specify any enterprise bean QL finder or select query for enterprise bean other than the query the query for the find by primary key method. Now we are considering restrictions in packaging restrictions. Entity beans are not supported with within .var files. These component types must only be packaged in the standalone EJB jar file and an EJB jar file packaged within an .EAR file. Entity beans are not supported with enterprise beans 3.2 Lite API. EJB 5069 error message. The bean's home or local home does not define a no arg create method. Solution: check the home or local home interface for the appropriate create method signature. Running the verifier will help identify the error as well. This is occurred in application server Sun Java Communications Application Server 1.0. Now we are focusing on this is the end of my presentation. Thank you very much for watching it.